So the inverse function. The inverse function is pretty much a reflection of the original function in the line y equal to x. And as it says there, it is a mirror image in the line y equal to x. Now, if it's a mirror image, what actually happens is, so the range of the original becomes the domain of the inverse, and the domain of the original becomes the range of the inverse. Now, an inverse function exists only if f is a one-to-one function. So if you want your inverse to be a function, then your original function has to be one-to-one. And the last really important thing that we should know about inverse functions is that the original graph and the inverse function will always intersect on the line y equal to x. In this example, we're looking at the function f of x equal to 2x plus 5. So we're asked to sketch the graph and state the domain and range. Now, remember, in order to sketch a graph, you do need to find the x and y intercepts. So the x-intercept for this graph, we're letting y equal to 0. And so you get 0 equal to 2x plus 5 minus 5 equals 2x minus 5 on 2 is equal to x. So the coordinate there is minus 5 on 2 and 0. Now the y-intercept, well, that should be easy enough to read off the graph, and you can see straight away there that our y-intercept is 5, so 0, 5. So plotting that graph, we have negative 5 on 2 and 0, so that's negative 2.5, which is there. Negative 5 on 2 and 0. And our y-intercept is 0, 5, so that's there. So that's the graph of f of x equal to 2x plus 5. And because it's a straight line, our domain and range are all real numbers. So the question did ask us to state that. So x is an element of real numbers and y is an element of real numbers. So part B asks, is it a one-to-one function? Now, you should recall that testing for a one-to-one function when it's a graph, the best way to do that would be to use the vertical line test. The vertical line test says that if you can drop a vertical line anywhere along that graph and it only ever cuts it once, then it is a one-to-one function. So therefore, if f of x is f of x a one-to-one function? Yes, it's a one-to-one function because it passes our vertical line test. In part C, they want us to find the inverse function. Now, when you're actually finding the rule for the inverse function, what you should actually do is swap all your x's for y's and your y's for x's. So instead of f of x, we have x, because f of x is like y, and 2x becomes 2y plus 5. And now what we want to do is make y the subject, so bring 5 across and divide by 2. So x minus 5 divided by 2 is equal to y. So my inverse function, let's use the right notation, f minus 1 of x is equal to x minus 5 on 2. Now, the domain of this would be the range of the original. Now, the range of the original was real numbers. So x is going to be an element of real numbers and y is going to be an element of real numbers. Again, your domain and your range swap around. So part D on the next page asks us to draw the inverse function on the same axis. And so what you can see there, 0, 5, the x and y swap around and that becomes 5, 0. And minus 5 on 2, 0 becomes 0 minus 5 on 2. So I've swapped those, that's the easiest way rather than using the rule, and I've drawn my line through them, and you can see that they intersect down the bottom there at this point here. That's your point of intersection, and that should be on the line y equal to x. So in example 14, the question says find the inverse function. Now you can see the function is in mapping notation or function notation, and we're told that this is the domain, if you remember, which is 1 to infinity, and the r tells us that they are real numbers in that domain. And there's our function f of x is equal to x minus 1 squared plus 4. And then we're going to have to state the domain and range. Let's just find the inverse function first. So remember, what we need to do is let x equal to y, or swap x and y would probably be better. So we've got x is equal to y minus 1 squared plus 4. So wherever you had x, you're going to put y, and wherever you've got y, you're going to put x. Now we want to make y the subject. So let's bring the 4 across, and we get x minus 4 is equal to y minus 1 all squared. And obviously we need to bring across the square, and the opposite of that is square root. And when we take the square root of something, it's going to be plus or minus y minus 1. Next thing to go across is the minus 1. So we have plus or minus the square root of x minus 4. Bring the 1 across is equal to y. Now, whilst we're looking at this, because that's not the final answer, we do need to consider the fact that the domain of our original function was 1 to infinity, which means the range of my new function, or my inverse function, is going to be 1 to infinity. 1 to infinity. So we're only looking at the positive side of things. So if you think about this, you should recognise our graph as a square root function, all right? And the square root function, which starts at 4 and 1, and we want the upper bit, all right? So we're not interested in anything. Remember, that's 4 and that's 1. We don't want anything below the 1. We're not interested in that bit there. So that minus is not what we're after. So my inverse function looks like this. F minus 1 of x is equal to the square root of x minus 4, only the positive bit, plus 1. Let's think about the range of our original function, which was this one here. Now, that's a parabola with a turning point at 1 and 4. So if I was looking at that, okay, that would be 1, 4. And which means my y values are starting at 4 and getting bigger. So my range there would have been 4 to infinity, which means now that my domain for my inverse function, which was the range of my original, is also going from 4 to infinity. So x is an element of that. Let's put it all together in mapping notation, because that's the way the question was given to me. So f minus 1 of x, okay, such that now my domain is 4 to infinity, and we know that they are real numbers within that domain. So f minus 1 of x is equal to the square root of x minus 4 plus 1.